Okay, day one, definition of derivative. Some of you might know a shortcut to doing derivatives that you might have learned in physics. However, when they say to find the derivative by definition of derivative, you must do it the way that I'm going to show you today. We will then be talking about the shortcut method and all of that stuff. But when we do definition of derivative, we have to do it this way. If it doesn't specify, then you're going to use the shortcuts. So they're looking at 2 points here on a parabola. We know the average rate of change is the slope of the line created between the 2 points, creating a secant line. As we bring our points closer together, they will eventually meet, creating a line tangent to the curve. This will give us the instantaneous rate of change. First derivative is the slope of the tangent line. Okay, so first derivative is the instantaneous rate of change. It's also the instantaneous velocity. It is the rate of change or velocity or slope rate of change or velocity at a certain instant, or slope at a certain, x value. So this is x comma f of x. Let's say now we go h units over to get to this point. So now this x value is x plus h comma f of x plus h. So if you think about it, when you do a slope, you go y minus y. So that's where they're getting this from. And then over the x minus the x, which if you do x plus h minus x, that's where they're just getting the h from. So that's where this formula is coming in place. Now, this is the slope of the secant line. But as soon as they put limit as h approaches 0, it's going to become slope of the tangent line, because if h goes off to 0, meaning there's almost no distance between these 2 points, this point is coming over, there's no distance or close to no distance, it's going to be a tangent line. It's going to be just 1 point as opposed to being 2. Now for notation, f prime of x, so f, and it's kind of like a little dash. It's not a 1, it's just a dash. And it's read f prime of x. Or dy dx. So it looks like dy over dx, but it's actually read dy dx. Or y prime, and that is read y prime. What they usually do is if the equation is a y equals, then your slope of the tangent line, your first derivative, would either be dy dx or y prime. If it's f of x equation, then they would use the f prime of x. Okay, so f prime of x equals the limit as h approaches 0 of f of x plus h, f of x plus h minus f of x all over h. So to talk about how to do f of x plus h, think about how you do f of 2, right? You would put 2 in for x in the equation, right? Think of how you do f of h. That means you'd put h in for x in the equation. So f of x plus h means you're going to put x plus h in place of x in the equation. So anywhere you see an x, you would put an x plus h. So that's what we're going to do. F prime of x equals the limit as h approaches 0. F of x plus h would be x plus h squared minus 2 times x plus h plus 5. That's putting x plus h in for x. Then minus f of x, which is the original function, all over h. So to be clear, this entire thing here is f of x plus h. This is f of x. Once you set that up, it becomes a lot of algebra. So x plus h squared, you're going to expand that out. That'd be x squared plus 2xh plus h squared. You would just, if you need to go off to the side and FOIL that, that's what you would do. Distribute the negative 2, it's negative 2x, negative 2h plus 5. And then distribute the negative, it's negative x squared plus 2x minus 5. All over h. Now, what you're going to notice happen, anything that doesn't have an h in it is going to cancel out. X squared, negative 2x, positive 2x, 5, negative 5. And that's because if you think of how we did limits in the last unit, so the f prime of x equals the limit as h approaches 0, we would plug in, right? That was the first thing of limits. But if I plug in here, I'm going to get 0 over 0 indeterminable form, right? If I plug in h is 0, I'm going to get the indeterminable form. So one of the first things we did in the last unit when we got the indeterminable form was factor, cancel, plug it in. And that's exactly what we're going to do. So we're going to factor out an h, which we would not be able to do if every term didn't have an h. We'll factor out an h so that we can then cancel and then plug in. And we're plugging in h is 0. So my f prime of x ends up being 2x minus 2. Right? We're doing the limit as h approaches 0. Now, write the equation of the tangent line at a given point. Well, that's up here, or at the given point. The given point was 2, 5. If I want to write the equation of the tangent line, this is my x, y point. I need to know my slope. Well, the first derivative is the slope of the tangent line. And we want to evaluate it at this x value, which is x equal 2, because we're finding the slope specifically at this point. So that's when x is 2. So this is my slope. So when I write the equation of the line, it's y minus the y coordinate equals m parenthesis x minus the x coordinate. Now for the next one, so first of all, we're going to do the same thing. F prime of x equals the limit as h approaches 0. F of x plus h, we're going to put a x plus h in for x, minus f of x all over h. Oops, sorry. F of x. This is f of x, 2x plus 4. Okay, so I'm going to distribute on the top 2x plus 2h plus 4 minus square root of 2x plus 4 all over h. Now, let's think back to the last unit. Again, when we did limits, we would always plug in. If I plug in h is 0, I'm again going to get 0 over 0 indeterminable form. So with what we have to remember is with radicals in the last unit, if we got 0 over 0 indeterminable form, what we did was we multiplied by the conjugate. So that's exactly what I'm going to do. 2x plus 2h plus 4 plus square root of 2x plus 4. Whatever I do on top of a fraction, I have to do the exact same thing on the bottom of the fraction. Otherwise, I'm not keeping it the same. I'm not keeping the fraction equivalent. Okay, so then what we would do is wherever we had the two radicals, we would FOIL through. Wherever we had the radical with the non-radical, we did not FOIL through. So here, if I do firsts, I get 2x plus 2h plus 4 without the radical. Outers and inners are going to cancel out. Lasts are going to be minus the 2x plus 4. I do have to put that in parentheses so I know to distribute my negative. On the bottom, I have h times square root of 2x plus 2h plus 4 plus square root of 2x plus 4. Okay, limit as h approaches, so f prime of x is equaling the limit as h approaches 0. On the top, 2x minus 2x is going to cancel. 4 minus 4 is going to cancel. So all you have left on the top is 2h over that h times square root of 2x plus 2h plus 4 plus square root of 2x plus 4. And we always wanted to get to the point where we could cancel. And that's exactly where we're at. We can cancel these h's. And then I'm going to have 2 on the top and square root of 2x plus 2h plus 4 plus square root of 2x plus 4 on the bottom. If I do the limit as h approaches 0, okay, that's going to wipe out this, right? If I plugged in h is 0, so I would have something that looks like this. So f prime of x equals 2 over, this is a 1 radical 2x plus 4 plus a 1 radical 2x plus 4, which can be written as a 2 radical 2x plus 4. So now if I cancel the 2's, that is my derivative. Notice I'm only dropping off limit as h approaches 0 when I'm plugging in h is 0. So my f prime of x is 1 over square root of 2x plus 4. That's it, simplified. So now the point they had given us top, they said at x equals 2. So this is different than the last one because the last one gave us the y coordinate. This one is not. It's just telling us when x is 2. So f prime of x is, we know, 1 over the square root of 2x plus 4. Sometimes in Calc, when we're going to plug in, we just drop a line and say we're going to plug in x is 2. And then I would plug in 2 for x. 1 over square root of, that would basically be 4 plus 4, which is 8. Or 2 radical 2. If I want to rationalize, that become radical 2 over 2 times 2, or radical 2 over 4. That is my slope. Now, because first derivative is the slope. The other thing I need to know here is what is the y coordinate? So I have to do f of 2. right? When you want to know the y coordinate when x is 2, you plug 2 into the original equation. So if you go back and look at the original equation, it was radical 2x plus 4. So let me actually put first, I'll just put what f of x is. It's radical 2x plus 4. So if we evaluate that at x equals 2, it's radical 2 times 2 plus 4, which is radical 8, or 2 radical 2. That is the y coordinate when x is 2. This is the slope. So my line goes y minus the y coordinate equals m parenthesis x minus the x coordinate. Okay, one more we're going to look at is a fraction. So f prime of x equals the limit as h approaches 0, f of x plus h minus f of x all, actually, we normally do all over h. Since this is a fraction, I'm going to say times 1 over h, right? The reason I'm going to do that is, so dividing by h is the same as multiplying by 1 over h, right? And I just don't want to have a complex fraction that I'm having to carry down. So I'm going to say times 1 over h. So limit as h approaches 0. I'm going to distribute through the top. Now, let's think about it. How would I subtract those two fractions? I would need a common denominator, right? That's how you subtract fractions. So I have to make a common denominator of x plus 4, x plus h plus 4. X plus 4, x plus h plus 4. Okay, so the first fraction already had a denominator of x plus h plus 4. So it needs the x plus 4. And the second fraction had the x plus 4. It needs the x plus h plus 4. So for the first one, I FOIL 2x squared plus 8x plus 2xh plus 8h. Here, 2x squared plus 2xh plus 8x. Limit as h approaches 0. So now, again, what you're going to notice on the top, 2x squared minus 2x squared is 0. 2xh minus 2xh is 0. 8x minus 8x is 0. So all I have left on the top is 8h over the denominator, right? When you subtract fractions, subtract the numerators, keep the common denominator, and then times 1 over h. This is exactly where I want to get to, because if I were to plug in right now, h is 0, I'm going to get 0 over 0 in determinable form. But if I cancel these h's, the limit as h approaches 0, actually, I probably could just do it at this point. So f prime of x is going to equal, if I do the limit as h approaches 0, that's going to be x plus 4. That's going to be x plus 0 plus 4. So this is going to be 8 over x plus 4 times x plus 4, which can be written x plus 4 squared. So that is the first derivative. The f prime of x is 8 over x plus 4 squared. Notation is very important here. So you keep limit all the way down until you're actually plugging in h is 0. This says at x equals 1. So if I take the first derivative and I evaluate when x equals 1, that'd be 8 over 1 plus 4 squared, 8 over 5 squared, 8 over 25. That is my slope when x is 1. I also, in this case, because they didn't give me the y-coordinate, I need to figure out what is the y-coordinate. So I take the f of x, the original f of x function that was given in the beginning. I plug in x as 1. And that is my y-coordinate. So just a reminder, this is my slope, this is my y-coordinate. So the tangent line is passing through the point 1, 2/5, right? X is 1, this is the y, which is 2/5. So when I write the equation, I'm going to say y minus the y-coordinate equals m, parenthesis, x minus the x-coordinate. That is my tangent line. Okay, that is it for day 1.